So we need to figure out what PQ is first for this, to figure out what these distances are. PQ is simply just going from P to Q, so like this. It's clearly minus A and then plus B, right? Reverse the direction as negative. So you now know what PS is. It's 4 on 9 minus A plus B. So that gives you minus 4 on 9A plus 4 on 9B. Now you need to find OS. OS is going from the origin to P, going from the origin to P, and then finally to PS. So it's OP plus PS. OP is A, as we've seen here already. So simply A plus the PS that we had. So that's minus 4 on 9A plus 4 on 9B. Simplify, you get 5 on 9A plus 4 on 9B. So that's your answer. And that's the correct answer. Okay. Now I'll ask you to sketch the graph of y equals to tan x. So now tan x has actually you have to remember this, a period of 180 degrees. So each kind of segment of the graph oscillates. So like when you have sine, it has a periodicity, so of 2 pi or 360 degrees. So every single loop is of 360 degrees in length. So in this case, tan x, you just have to remember that it has a period of pi. So essentially, it starts here at 0 and it goes like this up until 90 degrees and it converges. So and it diverges here. It goes up all the way and it never reaches 90 degrees. This is why when you say you put into a calculator, you put tan 90, it's going to give you undefined, okay? Because it never reaches that value. And then afterwards, has a period of 180 degrees. So it actually goes like this. So yes. So that's a length here of 180. So and then here it continues. Kind of just have to remember that. And then yep, that's basically your answer here. Now I'll ask you to solve the equation of 5 tan x equals to 1. So divide both sides by 5 and you get tan x equals to 1 over 5. Now you're going to have to solve this. So x equals to the inverse tan of 1 over 5. Remember the unit circle, it says here 0. So you want positive values of positive values of angle. When the angle yields positive values, you need to remember within this domain, you need to look at a unit circle. Remember the unit circle has ASTC, meaning for this part all the values are positive. This part only sine is positive, this part tan is positive, this part C cosine is positive. So once you get that value, you should get about 11.3 degrees. So solve this one, and then you need to add 180 degrees to get the other positive value. So it should be 180 plus 11.3. That gives you 191.3. So 19 it should be 11.3 and then 191.3 degrees. So that's the other value that gets positive. If you check the other ones, say if you put 90 minus 11.3, that gives you negative. because only sine is positive here. And then if you put 360 minus that angle, it gives you cosine angles. So only cosine is positive there. And you only want positive values. As you can see here, 1 on 5 is positive. Okay, that makes sense. So now we're going to look at this question here. The distance between two towns is 600 kilometers. Correct to the nearest 10 kilometers. A car takes 8 hours 40 minutes. Correct to the nearest 10 minutes to travel this distance. Calculate the lower bound for the average speed of the car in kilometers per hour. So average speed, if you think about average speed, that's speed equals to distance over time, right? And then if we look at the distance, it says here distance between two now is 600 kilometers. Correct to the nearest 10 km, so plus minus 10 km. Car takes 8 hours 40 minutes. So let's write it into decimal form. 40 minutes is over 60. So that's the amount of hours in the minutes, plus minus 10 minutes. Okay. Just calculate the lower bound. So if you look at the formula here, when you have a smaller distance here, that gives you a smaller value. So that's a lower value for the speed. When you put time, when you put a larger value, it also gives a smaller speed. So that's what you want when you calculate the lower bound. You want a very large time and you want a very small distance. So to minimize the distance, I'm going to look at what is happening? Okay, let's just change color. You're going to look at the distance. You're going to look at the distance and you want to minimize that distance. To minimize it, since it's correct to the nearest 10 kilometers, you can have 590 as the lower bound. So that's perfect. You have 590. 590 here. So 590. 590. That's your lower bound of distance. And then here 10 minutes. So you want to increase that time to get a smaller value for speed. So let's put 50 minutes, okay? So it should be 80. It should be 88 plus 50 minutes, so that's 50 over 60. And that's your lower bound for your speed. Okay? So this is going to give you the lowest possible value. And indeed you find that gives you about 67 kilometers per hour. So that's your answer here. Hopefully all of that makes sense. And then just have to make sure that you get the proper lower bound of the distance. And that essentially solves all your problems. Okay, thank you. Hopefully everything makes sense.